related to IR spectroscopy and the force constant. Here the problem is giving us two different molecules. One is HCl and the other is DCl. So actually the basic difference is in the presence of the isotopes of hydrogen. So we have H1 over here and we have deuterium over here in place of H1. Okay, so the question says the value of force constant for HCl is same as that for DCl. If the fundamental frequency of HCl is 2890, calculate the fundamental frequency of DCl. So where will we get the band of IR in case of DCl? If for HCl we get it at 2890 centimeter inverse. So since the force constant value relationship is given for both and the fundamental frequency value is given for HCl, so let's start with this formula itself. So mu is equal to 1 over 2 pi times under root of k over reduced mass. And let's say if I take the frequency of DCl over frequency of HCl, so it will be 1 over 2 pi and 1 over 2 pi, with I just cancel the 2 pi over here because they both are constant. Okay, so it will be equal to square root of force constant of DCl divided by mu of DCl, right? And so this will be divided by force constant of HCl over mu of HCl. Okay, so I can also write this expression as under root of k for DCl, okay, over k of HCl, okay, and into mu of HCl over mu of DCl. Okay, so now it will be easier for me to substitute the values and get the result. So mu of DCl I need to calculate, so this is unknown for me, but I have the value of mu of HCl, so I will write it as, let's say, mu of DCl over mu of HCl, okay, and mu of HCl is given to us as 2890. This will equate the right hand side of the equation. So let's do it over here. It is equal to k of DCl, force constant of DCl. It is saying that the force constant of both the molecules is same, so these two values will be same, so they get cancelled over. What do I get? I simply get mu of HCl over mu of DCl, so I just write it over here, mu of HCl over mu of DCl. Now let's try to solve it. So it will be mu of HCl, so m1 m2 over m1 plus m2 for both the cases. It will be 1 into 35 divided by 1 plus 35, okay, into 10 raised to power minus 3 because I want the answer in kilograms, divided by the Avogadro number. Okay, now this whole is divided by 2 into 35 because the mass is 2 over here in case of deuterium, over 2 plus 35. Again I just multiply 10 raised to power minus 3 and divide by the Avogadro number. Okay, so this entire thing is in under root. So when I solve this, I simply get 35 into 37 because these two values get cancelled, okay, and over 36 into 70, right? So the answer will be under root of 37 over 72, right? And I need to calculate the value of the frequency of DCl. So frequency of DCl will be equal to this term multiplied by the 2890. Okay, so what do we get? We get 2072 centimeter inverse. this will be the frequency at which we will get a band for DCL. Now you can see that the band for HCl in IR spectrum is at 2890, whereas it gets lowered in value in case of DCL. Okay,